paper and let me record this.
Cool.
Hold on a moment.
Yeah, you're good.
All right, so graphing these things, again, the thing you should always be thinking about is domain.
Okay.
Okay, and notice on this one that we can start at the top because that's the left.
Yeah, exactly.
In other words, x is less than or equal to 0. That's this whole area, all the way out to negative infinity.
Right.
So in that area is where we need the function x plus 3. Well, how do I
Okay.
graph x plus 3?
So to graph x plus 3, you would start at 3 and then go down 1 over 1 to the left
So
since it's less than.
it's less than or equal, so that's a closed dot there.
Yep.
And how do I find the second point? What's the slope?
It's down 1 over 1.
So the slope is positive 1.
What's that?
Be careful with that. For some reason,
Oh,
every student does this, and I'm not quite
okay.
sure why, but you said down 1 and over 1. Well, I could go down 1 and over 1. Would that be a point on the thing?
If you go down 1 and then to the left, like,
Ah,
I mean, it would,
there's
yeah,
the key. You got to say left or right.
yeah.
So if I go down 1 and left 1, now there's my function. I'm sorry, I didn't mean to draw it to the right of the x-axis.
Oh, you're fine.
So that's what it looks like.
Okay.
And check it, and that looks like a slope of 1.
It does, yeah.
And it's only to the left of the y-axis.
Yeah.
Okay, now what's our next interval? What's our next
Um,
domain that we care about?
y equals 2x.
Well, what's the domain? That's the function.
Oh, 0 is less than x, which is less than 2.
So between 0 and 2, in other words, there's 2. So
Uh-huh.
it's this area here that we're going to plot our next function.
Okay. And it's an open circle because it's no equal sign.
Okay, where do I start?
You'd start at 2 and then go to,
It's
well,
between 0 and 2. Remember, it's this area here. Let's
so
go
we would
left to right.
so we would start at 2 and then we would go
Now, what's
up
the
to the left.
y-intercept?
Um,
If the function is 2x,
uh-huh.
what's the y-intercept?
2.
No, that's the slope.
That's the slope.
0.
0, yeah. Yeah, my bad.
Always remember, you're always trying to put these in y equals mx plus b. Well, in
Okay.
this case, it's y equal 2x plus
Hmm.
0. There is no y-intercept, which means it's 0.
Yeah.
Okay? So I'm starting at 0, 0, right there, with an open
Okay.
circle.
Okay.
Okay, now what?
And then we would go up 2 and then to 1 to the left.
That would give us a negative slope. If I
Is
went
it
up 2 and 1 to the
it's
left,
positive?
it would give me something that looked like that, right?
Yeah, but it's positive, so you'd go up 2 to the right. Up 2 and
Up
then
2
1 to the
and
right.
right 1 is
Yeah.
where you want to say that. Up 2, right 1.
Okay.
Now I can just connect those 2 points and extend it to there. And open or close circle at that point.
It'd be an open circle.
Okay. Now the rest of the thing is how we're going to graph it in that area.
Okay.
Everything greater than or equal to 2.
Right.
What's the function?
So it would start at,
How do I graph? Well, first of all, what function is it when x is greater than or equal to 2?
when x is greater than or equal to 2, it's everything to the right.
Hold on. But what's the function? Right here is the functions. In other words, the first function was x plus 3. The second function was 2x. What's this function?
So it's 3.
How do you plot y equal 3?
You would just put the value at 3.
Start. In other words, I've got to graph it in this open region to the right of 2. Where do I find my first point?
At 3. On the y-intercept.
Is it open or closed circle?
And that'll be a closed one.
No, yeah, excuse me, sorry. But it's not the y-intercept. Notice. In other words, if I extended that line all the way to the y-axis, then it would be the y-intercept. But it doesn't actually intercept the y-axis at this point. It just, that's the way it looks.
Okay.
And notice now we have 3 regions. We have everything where x is less than or equal to 0. We have everything where x is between 0 and 2. And we have everything whenever x is greater than 2. And that's the way I want you to think about them, is the domain. In other words, you have separate areas of domain that are all separated by vertical lines, pretty much.
Okay.
Okay?
Yeah.
All right. Let's have a look at number 4. What's the first key point I need to look at on number 4? Where do you start?
You'd start y equals 2, y equals 4, and then y equals 3.
Always start in the upper right.
Upper right, okay.
Because that's where your domain is.
Okay.
In other words, before we plot these 3 functions, which are all horizontal lines, we got to know where to plot them.
Right.
Well, the first place to plot them is to the left of minus 3, right? Where it says x is less than or equal to minus 3.
Yeah.
So the first thing is what goes in that region there.
Okay.
And what is the function?
For that? Y equals 2.
Okay, how do I graph y equal 2?
So you go up 2 and then over
What's
minus
the slope? First of all, what is y equal 2? Is that a vertical line, a horizontal line, or a line that has slope?
Horizontal line.
Okay, that's all. In other words, the slope is 0.
Yeah.
Okay, where do I start?
You start at -3, 2.
Well, yes. Open or closed?
And that'll be in a closed one. And you'd go to the left since it's less than.
Correct.
Okay.
Put an arrow indicating that it's like that all the way to negative infinity. And then what's the next region?
The next region would be 2. Y equals 2.
No, what's the next region? What's the next domain?
The next main region would be
the domain.
Y equals.
Not y, the x. X, when I talk about domain, I'm talking about what, in other words, the first region was this region here. Yeah. Well, that was defined by x is less than or equal to minus 3. What's the next region? And this is an important concept with piecewise functions. You got to get this concept to understand them. That's why it's so important to me that we start in the upper right. Well, this is the next region. What does that say? The second.
Right. Yeah, it's 0. 0 is less than x, which is less than 2.
So what region is that?
The left. Oh no, that's a right. That's a right because it's positive. My bad.
It's the region between 0 and 2, correct?
Yeah.
So if I write 2 on there, we're talking this region right here.
Yeah.
Notice they skipped this region here, which is very unusual. I don't know if that was a typo and they intended to do that, but it doesn't matter. We're only gonna graph this function, y equal 4 is the name of the function, in the region between 0 and plus 2.
Okay.
What kind of line is that?
That's going to be a...
This program. You never know. If I accidentally leave it on erase and I go to write, it erases the whole line.
You're fine.
How do I graph? What's the function in that area between 0 and 2?
Y equals 4.
How do I draw that?
You put it on 4. Wait, yeah, you put it on 4, and
What
then,
line is it?
hold on. So it's gonna be an open dot. 1, 2, 3, 4.
Open dot at both ends.
Yeah.
And a horizontal line was what I was looking for.
Oh, my bad,
In
yeah.
other words, it doesn't have any slope. Whenever you see
No.
y equal to numbers, you know you're always looking at horizontal lines. And finally, the last region is this region there.
Yep, x is greater than 2. So we would start at 3.
Closed or open?
And that would be, let me see, closed.
And again, you need to tell me that's a horizontal line.
That's a horizontal.
Because
Yeah,
it's very important, because notice that horizontal lines all have slopes of 0.
yeah.
Whereas in problem 3, the slopes were 1, 2, and 0.
Yeah.
So the most important thing about graphing any of these is the very first thing you have to notice is what the slope is. And horizontal lines have a slope of 0.
Yeah.
All right.
Okay. Cool.
What else do we have? We have anything else on this page you need to cover?
No, that would be it on this page. And then, the next, picture.
Which is, I can't remember when I opened.
No, you're fine.
Okay.
Yeah, perfect.
Word problem. All right.
Yeah.
The first step of all word problems.
Identifying the variables.
Okay. Step A that they've listed there. So X, have you done this one already?
I've done some of it. Like, I got stuck on part C, like how to figure out that part of the equation.
Have a quick look. Okay, so X is the number of adult tickets. Y is the number of child tickets. And in this case, you probably should use 2 variables, especially because we're still on the part of algebra where you're doing multiple equations with multiple variables. Okay.
Right.
On Friday night, they sold 848 tickets for this amount of money. Let's talk about this.
Okay.
If you were running the cash register, what would your revenue be in terms of the variables? How much revenue do you get from adult tickets?
From adult tickets you would get 400.
$9, right?
Yeah. Oh, yeah. My bad. Yeah. So $9 there and then $6.
It's $9 times the number of tickets you have sold.
Right. So 9x.
9x. What do you get from the child's tickets?
$6. So it'd be 6y.
What's your total revenue?
6,711.
Right, not 848.
Okay.
In other words, there's your first equation.
Yeah.
Now, your second equation brings in the 848, but how so? What equation can I write that's equal to 848?
Just x plus y is equal to
Yeah,
848.
just have these backwards is all.
Okay.
Yeah.
Yeah, that's what I was, because like I went to like solve it and I was like getting like negative
Yeah,
numbers and it was
really.
just ugly.
That's going to make you crazy trying to solve it if you get them backwards.
Yeah,
But
it was
that's
ugly
why number one, the first part is so important.
for
Is
sure.
you've spelled it out. X equals the number of adult tickets. Well, your revenue equals the number of tickets times the price per ticket. I guarantee
Okay,
you, if you were running this show, you'd know that
for
because
sure.
that's the most important thing is that how much revenue you get.
Right, right.
Okay. Okay, now you just have two equations, two unknowns. What's going to be the best way to solve this?
Elimination method.
Okay, good. Now we have 10 minutes. We can either finish solving this, should we do that?
Sure.
And
Yeah, we could
then
do
look
that.
at one of these three equations and three unknowns.
Yeah, that sounds good.
I want to look at that, at least get you started on that. How do I solve
Okay.
this? If that's equation one, that's equation two. What's my first
hmm
step?
You would multiply the bottom equation by -9 to get rid of the x values.
Wouldn't it be better to multiply it by -6?
Um,
No,
yeah,
we have to solve for both x and y. And it
right.
doesn't matter which one we solve for first.
Uh-huh.
The key is to keep your numbers small.
Okay.
Well, I'm going to make my numbers smaller if I multiply equation 2 by -6 rather than -9.
Right.
I mean, I got to multiply this number 848 by whatever it is. So
hmm
let's multiply by smaller numbers. So
Okay.
let's do -6, and that way we'll eliminate y first.
Cool. So it'd be -6x minus 6y is equal to...
You have your calculator?
I do.
Good.
Yeah, let me get
You can
that out.
find that.
848 times 6. So it'd be minus 5,088.
Now, at this point, I always go through and I cross that out. Otherwise, you're just bombarded with equations in your face and
Yeah.
it's confusing. Now what?
Okay. Now we would add. So it would be 3x is equal to, what is that? Hold on.
600.
1,623.
And then x is equal to,
Hold on. 541.
so that's the number of adult tickets sold.
Right. And then we need a number of child tickets now. So we could plug it into the x plus y equation.
Yes. You're almost always going to plug it into one that I drew a line through. Because
Right.
that's always going to be a smaller equation than this two. And so
Yeah.
we never want to use bigger numbers than necessary.
No.
So if you plug it into there, you get 307 for y.
Okay.
So
Cool.
x equals 541 and y equals 307, which means they add to 848.
Okay.
All right. Now, we got enough time that we can look at. Do you have a preference? We probably only have time to look at one of these.
Okay.
Do you have a preference?
Yeah, we could do the first one.
All right. I'm not sure I can read the entire first one. Your camera looked like it cut off a
Okay.
little bit.
Yeah, I'm sorry. So it's x plus 4y minus 6z is equal to -1.
Second equation.
Um, and then the second equation would be, well, let me see, 2x minus y plus 2z equals -7.
And the third equation?
And then the third equation would be um, it's negative x plus 2y. Yeah.
All right. What's our strategy here?
Um,
First of all, we're going to
so
use elimination or substitution?
elimination probably.
Always.
Yeah.
Whenever you have three equations and three unknowns and they're in standard format, in other words, all the variables are the left of the equal sign, all the numbers are to the right,
Uh-huh.
substitution would be a nightmare. I wouldn't even know where to begin. But elimination works quite nice. Which
Okay.
variable we eliminate in our first step?
X.
Okay. Which
Okay,
two
so
equations should we use to eliminate x?
the first equation and the third equation.
Okay, so that's going to give us equation number 4. This is very
Yeah, which
important.
is
We're going to get equation 4 and equation 5. And they're going to both have x missing. What's equation 4?
So equation 4 would be 6y minus 10z is equal to 4.
Now, which two equations are we going to use to eliminate? We have to eliminate the same variable, x.
Right.
And we can use 2 and 3.
Yep.
We
I
could
was just gonna
use
say that.
1 and 2.
Okay.
What's the easier 2 to use?
Probably 2 and 3.
Yeah, because I can multiply by a positive number. I don't have to multiply by any negative numbers. So
Right.
what's the next step?
So we would multiply the bottom equation by minus 2, or plus 2.
Plus 2. So that new equation 3 is what?
So it'd be minus 2x, plus 4y minus 8z is equal to 10.
Okay. And now we're going to do what?
And then now we would add 2 and 3, 2 and the new equation together.
Okay. What do
So
you?
it would be 3y minus 6z is equal to 3.
Okay. Now we turned a hard problem into a simple problem.
Yeah.
In other words, now we have two variables, two equations. Let's solve it.
Okay.
What's my next step?
And then now you would put the 6y minus 10z equals 4 equation, and the 3y
How do I handle
minus
that?
6.
How do I solve for y and z at this point?
So to solve for y and z, we could get rid of the y.
Okay? How do I do?
So we could multiply the bottom equation by 2.
2 or negative
And,
2?
negative 2.
Probably works better to do your negatives at this point, and then you'll
Yeah.
be adding the two equations.
Okay.
For some reason, most of my students have a lot of trouble subtracting equations. Adding equations gives them no trouble. So what's the new 5?
So it would be minus 6y plus 6z is equal to minus 6.
Minus 6y plus 12z
Or 12z, yeah, my bad.
equals minus 6. In other words, we have to multiply every part of this equation by whatever we're multiplying it by. If we're multiplying it by minus 2, we have to do that term, and that term.
Right, yeah, my
Now,
bad.
add them 4 and 5 together. What do we get?
And then we would get 2z is equal to minus 2.
Which makes z equal to minus 1.
Yeah.
What's the next step? We have to solve for all three variables.
Okay. And then we could use the equation Minus 2x plus 4y minus 8z equals 10.
Oh, hold on.
Or,
We've got to go backwards in the same order. We can't go into one of these
oh, but,
equations that has three variables. We won't be able to solve for anything.
okay,
So
so
we have to go
minus,
into either 4 or 5 to solve for y.
probably 4 would be easier.
Which is smaller? The 5 that has the line through it or a 4?
Um, the 4.
No, the 5.
No, the 5. I was looking at another one, yeah. The 3y minus
The biggest
16.
numbers here are 3, 6, and 3. The biggest numbers here are 6, minus 10, and 4. So
Right.
I'm going to cross that one, cross it out, but that's what I did. So now this is going to allow you to solve for y only.
Yeah.
Okay, so substitute. So we have 3, actually that, I'm glad I did that. 3y minus 6 times minus 1. And I'm always recommending that you write it like this.
Okay.
In other words, don't try to do this in your head. Write it out first with the
Right.
exact z in parentheses. And now solve that equation for y.
Okay. So I got y equals minus 1 after like solving that equation.
Correct.
Cool.
So y equals minus 1 also. Now how do we solve for the third variable?
And then for the third variable, we would just plug it into the original equation.
Any
And
of the original first 3.
right,
Notice that any of the original first 3 all have an x, y, and a z, and we know what y and z are. So that'll allow us to solve for x. Now, normally I might choose the 3 that I've crossed out, but that solves for minus x. So
okay.
I would choose that one because notice that x is all by itself there, no coefficient. We're not going to have to make that last division.
Right.
So we got x plus 4 times minus 1. Again, I would always do it like this.
Okay.
If your life depended on it, you would do it like this also. You're not out to take any shortcuts in your head.
Right.
Okay, so now this is x minus 4 plus 6 equals minus 1. That's x plus 2 equals minus 1, which makes x equal minus 3. So there's your 3 solutions.
Cool.
And that's the reason you'll only get one of these on a test. You'll never have 2 of them because they take too long.
Exactly, yeah.
A full 10 minutes to do.
Man,
But
yeah,
that's the pattern you always want to do is always remember you got to create equations 4 and 5, and both of them have to be missing the same variable. So whatever variable you choose to eliminate as your first step, you have to eliminate that same variable with your second step, always using 2 different equations. You can't use the same 2.
Okay.
Okay?
Awesome.
All right. Dylan, have a good rest of your week, and I'll talk to you next time.
That sounds good. Do you think we could, we have a test on Friday over this stuff, like I have a couple more review pages. Do you think we could set up an appointment for tomorrow?
Sure. What time you want? Here's my Thursday, September 8th.
Okay, cool.
From 2:30 to 4:30 at this point. What time? Any time after 4:30 works.
Cool, yeah, so we have practice from 4 to 6:30 or 3:30 to 6:30. So do you think we could do like 7:30?
Sure.
All right, cool.
Put you down.
That sounds good. I appreciate it.
Sure. I will talk to you tomorrow night.
Okay, sounds good. Thank you, Mr. Cowan.
All right, Dylan. Bye-bye.
Okay, all right, bye-bye.